Hello everybody, welcome. Today I'll be talking about my favorite number over a million. This is part of the thing that all the math YouTubers are doing called mega fab numbers. My favorite number over a million is this number. 1246944 or 1,246,944.71162. So on. There's more to it. But why this is my favorite number. I'll tell you in a second. If we have to round it, I'll just make this a 5 and ignore that part. But yeah. So all the other people have perfect numbers, like no decimals, so that's pretty cool, I guess. But mine does have a decimal, so yeah. Now we're talking about n-dimensional spheres. We know 2 dimensions, 3 dimensions, we might know 0 and 1 dimensions. But do we know 4 dimensions, 5 dimensions? Some of you might know 4, a bit about it, right? Well, the general formula is right here, and we can look at this column, or this, column. For a circle, it's just pi r squared. For a sphere, it's 4/3 pi r cubed. For a 4-dimensional sphere, it's 1/2 pi squared times the radius to the 4th, and then there's more. But I won't be using this formula. I'll be using a different one. So the general is the volume is where there's n dimensions and we input the radius is equal to pi to the n over 2 over the gamma function of n over 2 plus 1 times r to that. Now what's the gamma function? Well, the gamma function is kind of the extended, more complicated version of the factorial function. The factorial function is just multiplying all the positive integers below that number down to 1. So 3 factorial is 6. 3 times 2 times 1. And there's more. But yeah. Now the gamma function is we can basically take the factorial of negative integers. We can do decimals, we can do negative decimals, we can do pi factorial, I think. Yeah, e factorial, everything like that. So how do you relate the gamma function and the factorial? Well, the gamma of n plus 1 equals n factorial. Cool. Now, it seems so simple so far, except we don't know what the gamma function is. The gamma function is kind of an ugly boy. It looks like this. Integral from 0 to infinity. You're already kind of scared, I can tell. We have e to the negative x. Oh, yep. And then times x to the n dx. So that's not really the nicest integral you've seen, right? Too bad. So what does my number have to do with anything of this? My number is the smallest number over a million, such that the volume of a well, here's the thing. First I had to solve for n, right? So I had to find the smallest n such that this formula is greater than or equal to a million. It's hard to explain. I'll tell you in a second though. So first I have to find my r. So let's define my r. We want to use an interesting number because interesting numbers are interesting. We already use pi. We'll use e. That's a pretty cool number, right? Okay, cool. We'll use e. So if r equals e, then what I'm trying to do is I'm trying to find the smallest number over a million, or I'm just trying to find n where the volume is greater than or equal to a million. And there isn't really an easy way to do it other than you have to graph it. Okay, that's cool. So we'll graph it. This red thing is a volume of any n-dimensional sphere. As you can see, it's right here. I added a slide. I used decimals, by the way. I added a slider for d, and I was testing out pi e. I just used and then I added a slider for n down here. You can see this bad boy. this is the actual value, and n ended up being 15. How did I get that? I'm about to show you. If you look here, we have a billion negative values, but we only have 2 positive values. Maybe there's more down the road, but we want the smallest one, right? This one over here is the first that occurs after this x equals 0 point or line, and it's 14.59. Now that's how many dimensions we need to get to exactly a million. But 14.59 dimensions isn't that cool. It's pretty cool. I'd say it's too cool. It's kind of weird having those fractal dimensions and all that. So I'm just going to deal with 15 since that's how we get a bigger number over a million. And when you plug in 15, we get this bad boy. My favorite number over a million. I have to say, it was kind of hard finding my favorite number over a million. I was gonna do 1,000,001, but then that was taken. And then I was gonna do some boring stuff like the biggest prime, or smallest prime over a million. That was also boring. So yeah, hope this makes it in. And thanks for watching. That's my favorite number. Oh, and if it's a decimal, then it's this number. If not, it's just 1, 2, 4, 6, 9, 4, 4, or 4, 5. Yeah, sorry. Cool. Yeah, if you guys want me to talk about the gamma function in detail and stuff like that, I can do that too. So thanks for watching. Bye bye.